So yesterday we talked about like how to find the areas of triangle, okay? And then today we're going to talk about intersections, okay, of two straight lines, okay? For example, if you have studied economics, for example, this is a demand curve, right? And this is a supply curve. So we want to find the intersection between these two straight lines. I mean the demand curve and supply curve. So which is this point, okay? So how to find the intersection point? Actually, it's just a simultaneous equation, okay? So previously we got the program for simultaneous equation, right? So let's see. So let's see example 1. Y minus 2x equals 4 and 4x plus 3y equals 17. So we can rearrange the term into negative 2x plus y equals 4 and then 4x plus 3y equals 17. So what should we enter for the calculator? We enter negative 2, okay, and then 1 because 1y, and then 4, and then 4 because 4x, and then 3, and then 17. So it will give you x is 1 over 2, and then y is 5, okay? So the point of intersection is 1 over 2 and 5, okay? So it's just some form 2 stuff, okay? So, and then you try part B by yourself, okay? So you pause the video yourself, okay? So let's check the answer. So you set up a simultaneous equation, okay, and then you press calculator. For example, you press 6, negative 7, 23, and 2, 7, and 11. So you will got the answer is 17 over 4 and then 5 over 14. So one point worth mentioning is that sometimes the straight line equation are given like this. So remember, when you enter the program, you have to move the constant term to the right hand side. Okay, so don't input 6, negative 7, and negative 23. Okay, it's wrong. Okay. So now I taught you how to find the point of intersection, right? And then now we come to another part. So how many points of intersection can there be for two lines? Okay, so for case 1, for sure, one intersection point, right? Okay, say like this. So one intersection point. Okay, and then the second case. Okay, you should have learned that, for example, in parallel lines, then there will be no intersection point, right? Okay, so for parallel lines, then no intersection point. The third case is that there are infinite number, 無限, okay, infinite number of intersection point. Why? Let's say this line and then this line. Okay, can you see that actually these two lines are the same, right? So we will say when these two lines coincide, 重疊啊，得唔得？ then they will have infinite number of intersections. Okay, so let's go to the next part. So you can try it out, okay, for example 2. How many intersections are there between these two lines? Okay, try out yourself. So let's check the answer. So actually you will find out that, okay, 9y minus x equals negative 3. You can try to multiply negative 1 for both sides, and you will find that actually these two lines are the same, right? So you will have infinite amount, 無限, infinite amount of points of intersection, okay, for these two lines, because actually they are the same line, okay? So let's try to do example 3 on your own, okay? So part A and B are easy, but I want you to spend some time to think of part C, okay? So I give you a hint, okay? So test if the hint is that test if MQ, like the distance between these 2 points, okay? Test if MQ is the radius, okay? I give you some hints, okay? You can spend like 15 minutes to work on this question. So I assume you finished the question, so let's take a look at it. So slope of L1 is negative 3 over 5. Okay. And then intersect with the x-axis as P, 0, 3. So actually, these two sentences already gave us the information of the equation of L1, right? So equation of L1 is y equals negative 3 over 5x plus 3. Okay? For sure, you can write it in general form. Okay? You multiply the equation, okay, by 5. Okay, so let's see. So 5y equals 5 times this. Okay, so the general form would be 3x plus 5y minus 15 equals 0. Okay, so that's the equation for L1. Okay, and then let's see what happens. L2 is perpendicular to L1. Okay, and then intersect with L1 at Q. Okay, which is a point on x-axis. Okay, so you know Q will be something like, say Q0. Okay, because it's an x-intercept, right? So the y coordinate should be 0. Okay, so let's take a look at part A first. So find the equation of L2. So actually, we got the slope of L2 already. Why? Because L2 is perpendicular to L1, right? So slope of L2 is negative 1 divided by negative 3 over 5, which is 5 over 3. So we got slope, but we haven't got a point, right? Okay, so how to find the coordinate of Q? So you can see that actually L1 passes through Q, right? So we can just substitute, okay, Q and 0 into the equation of L1. Okay, so equation of L1 is like this, right? So I substitute x as Q and then y as 0, and it will give you Q is 5. So you know that actually, okay, Q is 5, 0. Okay, but for sure, in your presentation, you have to let Q equals Q0, right? Okay, so now we got the slope and then we got the point, so we can use point slope form. So y minus 0 over x minus 5 equals 5 over 3. Okay, for sure, you can also let L2 be y equals mx plus c, and then you substitute the point. Okay, so 5x minus 25 equals 3y. So 5x minus 3y minus 25 equals 0. So that's the equation for L2. Okay, so I do not have enough space here, so I will like erase some of the stuff, but like you can still go back to the video to copy it. Okay, so from here I know the equation for L2 is 5x minus 3y minus 25 equals 0. Okay, so let's take a look at part B. Okay, so I read the question. L3 equation is x plus ky plus 12 equals 0. So L3 intersects with L1 at P, okay, and intersect with L2 at R, and M is the midpoint. Okay, so find R. Okay, so for sure, you know R is the intersection point of L2 and L3, right? So we can solve a simultaneous equation. But however, there's a variable in the equation of L3, which is K. So how to solve for K? Okay, so we can try to substitute for a point, right? We know that L3 passes through CO3. So we substitute x as 0, substitute y as 3. So it will give you K is negative 4, which means that actually the equation for L3 is x minus 4y plus 12 equals 0. Okay, so now we can solve. Okay, we can solve for R. Okay, so we set up a simultaneous equation. Again, you press your program. Okay, press 5, negative 3, and then 25. And then 1, and then negative 4 and negative 12. Okay, remember to move the constant term to the left. Okay, which will bring you xy equals x and 5. Okay, so here is x and 5. So yeah, so R is x5. And then for M, it's easy, right? because M is the midpoint, so you just use the midpoint formula, which will bring you M is 4, 4. Okay? Okay, so part A and B is some mechanical stuff, and then the important part, okay, is part C. So let's see. Let PR be the diameter of the circle C. So does the circle passes through Q? Okay? No, I got some grammar problem. Okay, so let's see. PR be the diameter. Okay, so imagine like you don't know this question in the exam. So how can you still get some mark? So you would try, okay, to find the length of PR, right? Okay, the length of PR. So the length of PR is x minus 0 square plus 5 minus 3 square. So it should be root, let me see. Yeah, root 60x unit. Which means that, okay, since M is the midpoint, which means that actually PM is the radius and MR is also radius, right? So PM equals MR, which equals root 60x divided by 2 unit, okay? So let's see. They ask you if C, the circle, passes through Q. So let's try to draw the diagram first, okay? Always try to draw the diagram, although it doesn't count for any marks. So let's see. If C passes through Q, that means MQ is also the radius, right? So that's why I gave you the hint. You need to test if MQ equals PM. Okay, so I will try to find the distance for MQ. So Q we solved that. Q is 5, 0. Okay. So let's see. So MQ, the distance is 4 minus 5 square plus 4 square. So it's root 17. Okay, so when you express in decimal place, you will find that actually these two are exactly the same, like the value. Okay, should be 4 point something. Okay, so you will say since MQ equals PM, so MQ is the radius. So yes, C passes through Q. Okay, so you copy first, and then I want to explain logic why we should test if MQ is the radius. Because you see, okay, what if C does not passes through Q? Okay, if C does not passes through Q, maybe the circle will be something like this. So you see in this case, for sure, MQ is not the radius, right? Because the radius should be here. So MQ should be smaller than radius. Okay? So we need to test if MQ equals to the radius, okay, for this question. So actually, the way to do it, the method is simple. You just use distance formula. But the logic behind is a bit hard, okay? So I hope you can improve, and then you can step by step to think of this advanced question, okay? So this is the part for the intersection of two straight lines, and then I would like to go to this page, which is page 15, okay? So in geometry, we have points that are so this is something like one-dimensional. Lines, okay, lines are two-dimensional, and then planes, 立體, okay, so it's three-dimensional, okay? So how to find the distance between 2 points? You know it, right? It's just like the distance formula you learned in Form 1. But here comes another question. How to find the distance between a point and a line? Okay, so I say, okay, I want to find this point to this line. Okay, actually, what does it mean by the distance of this point and this line? Because you can find this distance, find this distance, find this distance, find this distance, and then these 4 green lines, their length are different, okay? But you need to know, in mathematics, when we refer to distance, we must say we are inferring to the shortest distance, or you can call it the perpendicular distance, which is this distance. So let's let this point be, say, K, okay? So we are just finding the length of PK, okay? So the distance between P and L, like the point P and line L, actually it's just the distance of PK. Okay, so how can we find the distance for PK? So let's see. Okay, so it may be a bit abstract, but I will give you a numerical example later. Okay, so we got slope of L, right? We got slope of L because slope of L is negative A over B. And you know, since PK, the line, is perpendicular to L, which means that the slope of PK should be B over A, right? Okay, this one, the slope is B over A. And we also got P, this point, is XY. So theoretically, we can use the point slope form to find the equation of PK, right? Okay, we have the equation of PK theoretically. Okay， 即係我哋有 PK 嘅 slope，OK， 有 P 呢一點係咪可以 point slope form 揾到 PK equation？OK，then actually what's K? Can you find out actually K is the intersection point, okay, for PK the line and L. So again, how to find the intersection point? So we can set up a simultaneous equation, right? We can set up a simultaneous equation between the equation of L and equation of PK. Then we can solve for coordinates of K, correct? So when we have coordinate of K, you just use distance formula, then you can solve for PK. Then you can get the distance between P and line L. Okay, that's the flow. Okay, I know it's abstract. Okay, so let's go to some numerical example. Okay, let's go to page 17. So find the distance between L, 3x plus 5y plus 1 equals 0, and then point A, which is 2, 3. Okay, so you can also try to draw the diagram. Okay, so this is the line. And then this is the point. So this is point A. 2, 3. Okay, so we need to find the perpendicular distance, which is this. Again, I let this point be K. So you just follow the step. Okay, we find the slope of L first. Okay, so slope of L is negative 3 over 5, right? And you know, since AK perpendicular to L, so slope of AK is 5 over 3. And then we also have the points of A, right? So we can use point slope form to determine the equation of AK. So y minus 3 over x minus 2 equals 5 over 3. So 5x minus 10 equals 3y minus 9. So you will have something like this. So this is the equation of AK. Got it? Okay, so now, after we get the equation, what should we do? We find the coordinate of K by setting up a simultaneous equation, right? So, okay, we can set up a simultaneous equation between these two. Okay, so 3x plus 5y minus 1 equals 0, and then 5x minus 5 minus 3y minus 1 equals 0. Okay, so let's do a simultaneous equation. Okay, for sure you can do it through your calculator program, but I don't have the program in my hand now. Okay.